Okay, in this lecture, we're going to talk about data visualization with plots and images. Okay. Actually, this topic will spend 2 lectures for this week and next week. So the lab tasks also will have 2 tasks where you are going to do plots or images. So this is for the first one. Um, yeah. To begin with, we need to introduce the concept of graph objects. Okay. The objects here refer to both in the generic meaning and also in the meaning of object-oriented programming. Okay. We do not need to know object-oriented programming yet, the OOP yet. Yeah, but we're going to use the objects, so it's always helpful if you have some understanding of that. But for now, since we do not actually need to code for the objects themselves, so yeah, just know that they are objects. That's sufficient. And in MATLAB, we're going to introduce 3 levels of graph objects. The top level is a figure window. That's called the figure. Yeah, because you need a window to actually draw something on it. The second level is called axis. An axis provides a coordinate system so that when you're drawing something, you know how to convert the values in the data to actual locations in the figure. That's the role of the axis. So whatever you need to draw, okay, you need an axis for that. Axes are 3-dimensional intrinsically, yeah. If that's a Cartesian axis, like the XYZ coordinates, yeah. When displaying an axis, the default is 2D. That you only see 2 axes, X and Y. That's the default. In that case, it's just the third axis is perpendicular to the screen. Yeah, but you can still rotate the axis around. So I'm going to play with something here. Okay, yeah, a plot. The third level of the objects is a plot. Okay, a plot is a particular visualization of a set of data, such as a curve. Okay. Yeah. So to plot something, you have to place it within an axis. Now this can be created with simple commands. So let's do this. Yeah, that's figure. That will create a figure for us. Okay. And if I type axis, that will create the axis in the current figure. Okay. And then I want to plot something. How about this? Okay. Yeah, so that's a line plot of this. Okay. Of course, there are some interactive ways you can play with this plot. Okay. Yeah, but for those, you can just play with it because that's the interactive part. And what we're going to do is to, yeah, write program about it. But there are some things that I'll let you know. For example, um, how to rotate the thing. Yeah. you can see that for some of them, it's actually a three-dimensional axis. Yeah. Okay, let me close this window. Yeah, those are just for fun. This is a visualization of the an example of the three levels of objects. Okay, the window is the figure. There are four axes in the window, and there are the individual plots. Okay, there are many types of plots in MATLAB. If we place those in a hierarchy, it's like this. Okay, the figure is the most outer container. Okay, and the axes are placed in figure, and then you can plot in within axis. Okay, so axis an axis is a container of a plot or multiple plots. Okay, in addition to plots, you can also have what we call other graph objects within an axis. Okay, usually those graph objects are just annotations that you can add. Yeah, those are not data but annotations you can add to show the data better. Okay. Yeah, those including like text descriptions, figure titles, legends, arrows, many different things. Yeah. They are placed within an axis because you need to know where to draw them. Okay, where to place those graph objects with your plot. Okay, so they have to be in the same axis or the same coordinate system. So how do we create and access graph objects? Okay. The creation is easy if we just do a manual creation like this. Okay. Yeah. Each command will create the corresponding object. Yeah. Actually, the object itself is returned by this command. So I can actually keep the object if I want to do some modification to it later, like if I do this, figure is the command figure returns a figure object which has these 5 properties. Okay. One thing particular about figure is that it has a property called a number. That number allows you to access a particular figure later very conveniently if you actually display multiple figures. You create many figures and you want to be able to access one particular one that you want to draw on that figure, then you have to use this number. Now, I can also create figure with a particular number. Yeah, as long as it's a positive integer. Okay, so this figure has the number 100. Yeah, it's like its ID. Now, when we're doing drawing something, generally, if you have multiple ones, the drawing is done on the current figure and current axis. Okay. You can use the functions GCF and GCA to return those objects. GCF means get current figure, and GCA means get current axis. Okay. Those are usually the most recently used figure and axis, or for the figures that can also mean the figure on top. Okay, the figure with the focus now. Okay. Yeah. And if you do something like do a plotting without a specified container object, okay, if one exists, okay, that the current one will be used. If none exists, like if I call close all, that will delete all the graph objects. Okay, there's no figure window now. And I try to plot something, it will be created. Okay, a figure and an axis will be created to contain this plot like this. Yeah. we have talked about figure numbers. So next, how to place multiple axes in the figure. Okay. The automatic way, like we just did, just create one axis because that's all you need. If you want to have multiple axes in the figure, the first way is to explicitly call the command axis for creating each axis individually. Okay. This way allows you to place each axis, arrange its position, the size in the command, and so you can have a custom figure the way you like. Okay. Of course, it takes a little bit of design. You have to think about how to place your axis around. Okay. Um, Later on, when we get to the topic of app building, okay, we can to write GUI programs. Okay. In those cases, we will be able to use some drag and drop tools to draw the axis on the figure. Okay, but that's for some later in the semester. Yeah. Okay. The second method is to use the function subplot. Okay. Each call to the subplot will give you an axis in the current figure. But the interesting thing about it is that it will arrange the axis as though that there will be multiple axes arranged in a grid. Okay. Yeah. So instead of just doing this plot, I add the subplot to it before it. Okay. Okay. So this is interesting. Okay, we get an axis, but the positioning of the axis is like as though there will be 6 axes in the figure. Okay, in 3 rows and 2 columns. Okay, those are specified here. 3 rows, 2 columns, and that's the index 1 among the 6. Okay. So I can add another axis to this, like the fourth one. Okay. How about I just do this? Yeah. So you repeat this, you can fill the figure with multiple plots, or in each different axis. Okay, that's number 4. It's in the order of 1, 2, 3, 4, 5, 6. Like that. Okay. So it's very convenient, and the position and the size are just determined automatically. Now, how do we play with different kind of plots to modify the appearance, etc.? Okay. For the basic 2D types, you can see we use 2 vectors of the same length, okay, like this. That's x vector, y vector, x vector, y vector. Okay. The default is line plot. Okay. If I just plot something, I will do another one here. This time I just plot some like that. You see only one vector. Oh, the figure disappears. Okay, let's bring it up. Oh, I close it. Sorry. That one should be figure 1. Okay. Yeah. This is the supply we just created. I'm going to make it a little bigger so easier to see it. Okay. That's the supply we just created. You can see that we only specify one vector, and that will be treated as y, so that's x. The x is created automatically. Yeah. If we want to specify an axis, okay, a particular axis, not just the current axis. Then we can supply it as the first input argument to the plotting function. And in that case, the plot will be placed in this particular axis. This format applies to many other plotting functions. So we're not going to mention them all later. Yeah, just know that there's almost always this option for you to specify the axis to do the plotting. Okay, then let's play with some basic plotting properties. Okay. Let me close all figures and I'll just use one plot. Okay. Yeah, this is the basic form. Okay. The easiest way to modify the appearance is using some predefined strings. Okay. The string can have up to 3 parts, but you can always just use 1 or 2 parts of it. Okay, this one has complete 3 parts corresponding to 3 different things. Okay, like in this example, O corresponds to the marker types, which are the circles. This represents straight lines, just line plot. This is the color, that's magenta. So if I redo it like this, okay, you can see this is what it has, the color and the marker. Okay. And of course I can play with it, like I can change the line type, I can change the color, like that's blue. Right. Yeah. And there are other options like you can do, but these are the convenient ones. Right. If I skip that line type marker, like just doing this, then what I get will be just a scatter plot actually, if no line type is specified. In addition, you can have many what we call the name value pairs of properties in MATLAB. These are usually specified with strings or sometimes numeric values for you to play with. Okay, there are too many, so you need to check the documentation. But I'm going to just give you a few examples here. Okay, place this here. So, for example, let me do this, and I play with the line width. Okay. Yeah. So that's called a name value pair, and they can be stacked. Okay, and in any order. Right. Yeah, like I want to do a custom color. Yeah. For example, this will be more like an orange color, which does not have a pre-specified name. Alright. So those 3 are RGB values in 0 and 1 range. Okay. So these are just 2 example properties. Okay. Name value pairs of properties. Yeah. Let me stack them. So just they can be do many of this. Okay, in MATLAB. Okay, its parser will handle these things for you. Okay, with the custom color and the custom line width. Okay. Yeah. For now, we have only placed one axis, one plot in this axis. What if we want to have multiple plots, like 2 curves, 2 functions, or sometimes different types of plots? Okay. So there are 2 methods. The first method actually is less used because it's not very flexible, but we're still going to introduce that, is to use arrays, 2D arrays or matrices, okay, where each pair of column vectors will give you a line plot. So, yeah. So, for this example, I do not have X represent, so I have to specify this first. Okay. So here there are how many column vectors? Actually, there are. Oh, okay. Sorry, I typed something wrong. That should be the semicolon. Okay. So there are 10 pairs of column vectors. Okay. So when I plot them, okay, let's see what happened to the figure. Okay. You can see there are 10 lines. Okay. Yeah, 10 lines here. Yeah, because each pair of column vectors are drawn as a band or as a plot. So there are 10 plots. The colors are assigned automatically. There's some pre-specified ordering in MATLAB. Of course, you can change that. You can specify those ordering of colors or specify your own colors in this plot command. Yeah. If I do something different, because right now there are only two pairs of column vectors. Okay. So, okay, let me close this. And then the more common way of doing it is to use a command called hold. Okay. The standard approach of MATLAB is that when you plot something to a figure, the old content is erased. Okay. So each time I call plot, it's a brand new plot. Okay. Yeah, I think. Let me bring this up again. I plot X and Y. Okay, and then I plot X, Y plus 1. Oh, maybe you do not see real change, but actually it's the y-axis is changed. Maybe I'll draw something that's make it a little bit different. Okay. Yeah. You can see the old thing is gone, erased. Right? Yeah. Unless you want to hold it. Okay. Yeah. So I type hold on. That means that when I draw the next plot on the same axis, okay, the original content will stay there. Now I'll plot this. Maybe I should use a different color. Okay, that's red. Okay. So right now we get the two plots. Okay, and each subsequent, the hold is still on for this axis. Okay, and until you call hold off. Okay, so it's more or less like a switch. Yeah, you switch something on and off. So maybe I'll have to make this a little bigger. And then another color like magenta. Okay, yeah, it's still there. So this is convenient, and you can overlay different things like the image with annotations, yeah, and the lines. Okay, yeah, they can all be placed on the same axis. Yeah. For the next few slides, we're not going to talk too much about do too much example, yeah, because you can just play with them. Yeah, those are just functionalities. Okay, like axis. Okay, here we talk about the command AXIS. In MATLAB, when we talk about AXIS, is the usual meaning of like x-axis, y-axis. Okay, so each AXES axis has the x, y, and actually z axis. Okay, the pronunciation are the same, so yeah, sometimes that can be confusing. Yeah, do not confuse them. Okay. So this refers to the actual like x and y axis. Okay, yeah, this is the way to specify the range with 4 values. If you have 6 values, then the third pair will be the minimum and maximum range of the z-axis. Okay. Yeah, and then there's those auto, manual, tide, those things for you to adjust the um, range. Okay, the auto, of course, that's default. Tight just means it will actually be tight. Just use the um, minimum and maximum of the data coordinates, yeah, as the axis range. Okay, whether to draw the axis or whether to draw the outer box. Okay, yeah, those are toggle switches. Yeah, and there's the aspect ratio, x and y. Okay, of course, again, normal is default. Yeah, that means it's determined automatically. Equal means the equal aspect ratio, 1 to 1. Okay, square means the box will be square. Okay. And then this one, this is more, you need to have better distinction. Okay, that's about whether it's a right-hand coordinate or left-hand coordinate. Okay, xy means right-hand coordinate system. Okay, ij is a left-hand coordinate system which is preferred for displaying images, because for images usually the origin is the top left corner, so the vertical coordinates actually increase downward. Okay, so it's the opposite for the vertical coordinates in the regular xy coordinate system. Okay. Yeah, let's look at our figure. Bring up our figure here. Let's see. You see the vertical axis switch direction. Okay. Back to normal. Yeah, so that ij thing, that's when you're usually that's used when you're displaying images. Okay. Yeah. And then how to add text in the 2D plots. Okay. There are particular type of text, and they are generic text. Okay, particular types like the axis labels, the tick labels, the figure title, and you can add legend. Legend is associated with axis, so you draw one legend for each axis. Okay, that can be created automatically. And then for generic text, if you just want to draw any text, okay, yeah, those are all the properties that you can use in a name value pair. And of course, you need to specify the location, okay, the coordinates within the axis. Okay. Yeah, the interpreter of the text, okay, MATLAB automatically use an interpreter based on TEX. Okay, yeah, on the TEX interpreter to allow you to add some formatting or special characters to it. Okay, but you can modify that interpreter. Yeah, we're not going to go into detail, but you can look for them in the documentation. Okay. Yeah. We have said that for graph objects, you can actually retrieve and store the object for later assessment. Okay. That will allow you to modify the, for example, a plot after it's already created using the standard format of get and set. Okay. Those two functions are generic functions in MATLAB. Actually, they are used in many other programming languages as well, just for you to modify or access or modify objects, properties of objects. So let's get back to the figure itself. Okay, but to modify something, I'm going to add a plot to it. Okay, so let's save the plot. That's a plot. Maybe I'll do this. Okay. Okay, you see a plot here. Okay, and then you see all its properties. Okay, so I can get the property like the color. You get the color, and I can set the properties. For example, I can set color to some green color. You see how it changes in the figure? Yeah, right now that line is green. Yeah. Yeah. So this for the graph objects, but you need to know that this kind of format is used in all kinds of objects in MATLAB and very similar to some other programming languages. Right. Yeah. Then very quickly introduce some additional 2D plot types. Okay. They're listed here just so that if you want to plot something like those, you know that they exist. Okay. For this, I'm not going to do examples. You have to look for the documentation yourself if you want to use them. Okay. For example, there's a polar coordinate system. And for XY plots, you can have log scale. Log will give you log scale axis, both x and y, and semi-log x and semi-log y. Well, that's just what they means. Yeah, and the usage are just in place of the function plot. Okay. So they will create a plot object. Okay. Yeah, and then you can have double vertical axis. Okay, yeah. In sometimes we have two y-axis on the left and right sides of a plot. Yeah, they have different scales, different meanings. Yeah, and in MATLAB, there are actually two overlapping axes. Okay, so that's called plot YY. And then, of course, there are a large variety. Yeah, the list here is not exhaustive, just to show you some variety. Yeah, again, look for them in your documentation. Like those are discrete ones. The scatter, discrete, I mean discrete in the x-axis. Okay, yeah. So the scatter plot, stem plot, those are stair plot. Yeah, from the figure you know what they mean. And for statistics, the pie chart, the bar plot, the bar edge just draw horizontal bars. Like these are vertical bars. Bar edge is for horizontal bars, and that's the area plot. Yeah. And finally, we're going to introduce function plots. Okay. The function here is not a function in programs, but a function in the mathematical meaning. Okay, like something like a y of x, y equals f of x. That's a mathematical function. Okay. Yeah. Usually, when we want to plot a function, what we do is by sampling it over some x values to get a set of y values, and then we use a plot function to plot them, plot those points. Okay. Yeah, that's not difficult and provides some good control about how you want the function displayed. Yeah. But sometimes if you just want to quickly see the property of some functions to have a quick visualization without going through all the sampling stuff, sampling display stuff, yeah, and MATLAB provides some convenient function for you to do this just for the visualization thing. Okay, yeah, the most basic form is the function called func. Okay, the function here, that's a function in programming. That's a function. Okay, that's a function in mathematics. You have to distinguish them. Okay. So it will plot the curve of this function. Yeah, just directly. Of course, you can specify a range of x. Yeah, but you don't need to actually do the sampling. And the whole thing can be done just in one statement. And then this is a direct way, and then there's the implicit way which plot the solution of this function. Yeah, yeah. This is not y being f of x, but it's the solution of this thing, and you can probably get multiple curves. Yeah, and then for the three-dimensional version, what you get is the parametric curves. Okay, so you have to define three functions, x, y, z individually over a parameter t, and then it can be plotted for a range of t. Okay. Yeah. So for all of this, it's just very convenient to do one statement visualization of functions. Yeah. Well, we're not going to talk more about this until later, because to actually use these programming functions, we need to be able to use and code function handles. Okay. That's a topic that to be covered later in the semester. So at this point, just so that you know, these functionalities exist in MATLAB. Okay, so this is for today's lecture.